All right, video number 2. Sorry, this is a long set of notes for today. It won't always be like that. So, transformations, we're going to recap, are operations that maps the original figure called the preimage. Get something smaller than this. No, that's fine. Onto a new figure, the image. A transformation can change the size, the position, or the shape of a figure. So any of those things can change in a transformation. Now, a rigid motion, the only thing that can change is the position. So when we reflect, it is a flip over a line called the line of reflection. Each point in its image are the same distance from the line of reflection. So you can either reflect over the x-axis or the y-axis. Okay, or we have these vertical and horizontal lines, which we've talked about a couple times this year. We have x equals, which is a vertical line, some number, or y equals some number. Now, diagonal lines, we have y equals x, or the opposite with a negative slope, y equals negative x. So I'm just going to go through one problem each. There's 2 ways to do all these. You can do some of the points in your head, which a lot of students in the past have chosen to do, or you can graph and then flip. So we start with triangle ABC. I'm only requiring you to end up with the points. You can use this if you want, or you can just do it in your head. So we start with -4 up to, this is A, B is at 1, 2, 3, 4, 1, 2, 3, 7, and C is at 5, 1, 2, 3, 4, 5, up 1. Okay, we want to reflect over the x-axis. So we learned that we're going to change the y. Now, if we wanted to do this on a graph, the first thing you want to do is identify the x-axis. The x-axis is right here. Okay, now you can do this by hand. We're going to run 1 to the line, so we want to maintain the same amount of distance, so we run 1 over the line. That's C prime. B is way farther from the line, so he has to run 1, 2, 3, 4, 5, 6, 7. So he's going to continue running or hopping 1, 2, 3, 4, 5, 6, 7. And he ends up B prime down here. A only has to hop 1, 2, so she continues 1, 2. Okay, now there's our reflection. We reflected it over that line. But we learned we can just change the y's. So what I would do, A prime, the x's are not going to change. So I'm just going to copy all of those down. Now what happens to all of our y's? Well, this was +2, so now it's -2, -7, -1. Okay. Now over here, we have the y-axis. So you can do the method where you hop, or we know that the y's are all going to stay the same. So I'm going to copy down 2, 5, 3, 0. Then we're going to change all the x's to -1, -2, -8, -7. All right, so you can fill in those. Now, number 5, I'm going to go ahead and plot my points. We have 1, down 1, J, or 1, 2, up 1, 2, 3, K. L is at 1, 2, 3, down 1, 2, L. Now we're reflecting over x is equal to 4. So that is to the right 1, 2, 3, 4. We want to reflect it over this line here. So you can just hop and go 1, 2, 1, 2. There's K prime. L only requires 1 hop 2, so 1 hop over, L prime. J is going over 1, 2, 3, hops 1, 2, 3. J prime. Okay, now take a look. What did not change when we reflected over x equals 4? Well, we only moved left or right. We didn't move up or down at all. So all of our y's stay the same. So we have -1, 3, -2. Well, we have to figure out how far the 1, the 2, and the 3 are going to move. Okay, well, 1, what do I have to do to get to 4? Well, I have to add 3. So I'm going to add another 3 to 4 and get 7. 2 has to add 2 to get to 4. So we're going to add 2 to 4 again. We're at 6. 3 has to add 1 to get to that 4. So you add another 1, 5. All right. That's a little trickier, but some of you that like to do things in your head, it makes a little more sense. Okay, so let's try it with the y's. If y is equal to 2, we're hopping over this line right here. We're changing how far we're going up or down, so all of the x's stay the same. -4, -2, 6, and 4. Now the y's, I have to get -4 to 2. Well, that requires me to add 6. So if I go from -4 to 2, I add 6. So I add another 6 to 2. I'm at 8. 0, I have to add 2. So I add another 2, 4. 1, I have to add 1. So I add another 1, 3. -3, I have to add 5. So I'm going to add another 5 to 2. I'm at 7. All right. So these are tricky. Please pause the video as much as you need. Now, x equals y, or y equals x. These ones are actually easy. This is reflecting it over this line right here. So the distance from the y-axis becomes the distance from the x-axis and vice versa. So all that's happening are these guys are trading places. So for x, we move our -2 over and our 5 goes there. Y here, our 4 takes first place, -3. Z is a +1. The -1 shifts over. All right. Now you saw an example of this one right here where y is equal to -x in the notes. It was the very last one. So not only are they trading places, they're trading signs. Okay. So y equals -x. They trade places and signs. Y equals x, they just trade places. So here we go. A, 3 is going to shift over, becomes a -3. 1 goes over here, becomes a +1. B, 6 takes the lead, but becomes a -6. 0 is one of those that we don't have to worry about. It just shifts over because it can't become negative or positive. Over here, 3 moves over, -5 comes through. This goes over as -3. This one doesn't matter. They're just going to both become negative. All right, so that was a lot. Sorry, I should have said y equals -x is flipping this one. You can still hop this way if you wanted. All right, so good luck. Remember, 10:30, I'll be available for questions. Please take advantage of that because this is one of the trickier, more particular lessons that we've had. So I hope to see you guys at 10:30.